Welcome to Eureka Math. I'm Mr. Schenkel. This is Grade 8, Module 4, Lesson 27. Let's get started. Well, we've got some systems of equations that we need to solve. And before we go ahead and solve these using substitution, I first want to see if we can find out if there's a solution or not. Because if there's a solution, then we can go about solving using substitution. If there is no solution, then I don't want to go through all of that work for nothing. And if there's infinitely many solutions, same thing. So we can find out if these systems have a solution just by checking the slopes of the two equations. So if I look at this first equation, y equals negative 3/4 plus 1. That's slope-intercept form. So I can easily see that the slope is a negative 3/4 and the y-intercept is a positive 1. And then the other equation is in slope-intercept form, standard form. And when we're in standard form, we can also identify the slope from standard form. And we can do that by this method. And once you know this, you don't have to do this every time. But let's take a look at standard form, ax plus by equals c. And let's manipulate this equation so that it is in slope-intercept form. In order to do that, I would have to subtract the ax from both sides. And that would give me by is equal to a negative ax plus c. And then I can further isolate the y by multiplying by the reciprocal of b, which is 1 over b, and doing the same thing to this other side. All right, and when that happens, we get y equals negative a over b x. That's distributing the 1 over b. And then plus 1 over b times c is c over b. So now I can see that my slope is a negative a value over a positive b value. And if we go up here to this equation, slope then would be equal to, our a value is a 3, so that's a negative 3, over our b value, which is a 4. And now I can see that the slopes are the same. So that means one of two things. Either these are parallel lines and they're never going to cross, which would mean no solution, or they're exactly the same line and they cross everywhere, so that would be infinitely many solutions. So just knowing the slope tells me that that's one of two possibilities. Now I just need my y-intercept. Well, the y-intercept is here, and that's our c value over our b value. So for this first equation, our y-intercept is our c value 5. All right, that's 5 over our b value 4. So now I can see the slopes are the same, the y-intercepts are different, which means these are parallel lines. And parallel lines will never cross, so there is no solution to this system. There is no intersection point. So I don't have to go ahead, I don't have to, solve for the solution, because there is no solution. And to just prove that, let me get rid of this and I'll show you what I mean by no solution. I know that y equals this expression, negative 3/4 x plus 1. So whenever I see a y in the other equation, I can substitute negative 3/4 x plus 1 for that y. And so that's what I'm going to do. I'm going to rewrite 3x plus 4 times y. Well, our y, we know, is equal to a negative 3/4 x plus 1, and that's all equal to 5. And then if I just simplify, I get 3x plus distribute This is the 4's cancel. I get a negative 3x. So that's a negative 3x. And then 4 times 1 is 4. So plus 4. And that's equal to 5. And then when I simplify further, I get a positive 3x and a negative 3x. Well, they cancel each other out. So I get this solution, 4 equals 5. And obviously, 4 does not equal 5, so that means no solution. So I can avoid doing all of that work by just checking the slopes and the y-intercepts. So that's what we're going to do for the first few here, is just check to see if there's a solution. If there is, we'll solve it using substitution. If not, then we don't have to do all that work. All right, so remember from our work on the last one, the slope is equal to a negative a value over the b value, and the y-intercept is equal to our c value over our b value. So we can check the slopes and the y-intercepts of both these equations. So let's do the first one first. 7x plus 2y equals negative 4. My a value is a 7, so my slope is going to be a negative 7 over 2. And the y-intercept is going to be, our y-intercept, that's b, is equal to a negative 4, that's the c value, over 2, which is a negative 2. So this line crosses at negative 2, crosses the y-axis at negative 2, slope is negative 7/2. Okay, so let's check on this other one. X minus y equals 5. Well, the slope would be a negative a value, which is a 1, over our b value, which is a negative 1. So our slope is 1. And I can stop right here because I can see that the slopes are different. We've got a negative 7/2 for one slope, and we have a positive 1 for the other. They are going to cross each other, so I know for sure there is one unique solution to this equation. And I'm going to show you a way to solve that later on. Number 3. By the way, this is one unique solution. All right, next. Let's check our slopes. So for this first one, it's a negative, the slope is a negative a value, negative 9, over our b value, 6, which is equal to negative 3/2. There's our slope. Our y-intercept is the c value, 3, divided by our b value, 6, which is simplified 1/2. So we have slope, negative 3/2, y-intercept, positive 1/2. And now we can check the second equation. Our slope is a negative 3 over 2. That's the same. So these two lines are either parallel or they're the same exact line. And we'll know once we check the y-intercept. And the y-intercept is our c value, 1, over our b value, 2. And I can see that they are the exact same line. These two lines are the same line, so that means infinitely many solutions. These two lines are going to cross everywhere. Infinitely many solutions. There's an intersection at every point. All right? Number 4. Now we're going to solve using substitution. Well, I know that I could check these and find out what the slope is, but on these problems we're going to practice using substitution in order to solve these systems. Now, you're going to see these in a couple of days, and you're going to say, why would I ever do substitution on this? I should just, multiply and eliminate. And I'm going to show you how to do that in lesson 28. But right now, we're going to use substitution. So I'm going to take this x plus 7 equals, x plus y equals negative 7. And I'm just going to change that to slope-intercept form. So I'm going to subtract x. We get y equals a negative x minus 7. So now I know whenever I see a y, I can substitute negative x minus 7 into that first equation. So let's go ahead and do that. Rewrite 3x plus 3y. Well, our y is this. So I'm going to substitute negative x minus 7, and that's equal to a negative 21. All right, now we'll simplify 3x. 3 times the negative x is a negative 3x. Oh, you can see what's going to happen. 3 times the negative 7 is a negative 21, and that's equal to negative 21. A 3x and a negative 3x cancel out, and we get negative 21 equals a negative 21. And that's true, and so that means this has infinitely many solutions. In fact, they're the exact same line. I can also check that by multiplying through here by 3, and I get 3x plus 3y equals a negative 21, and they're exactly the same if I scale that equation up. All right, so using substitution, we still can decide whether it's infinitely many, no solution, or a unique solution. All right, number 5. Well, I've got a nice slope-intercept form here, so that is y. So when I rewrite my equation below, I can just substitute that for y. So I get 3 times y. Well, that's 3 halves x minus 1. Okay, that takes the place of this y, is equal to x plus 2. Now simplify. 3 times 3 halves x is 9 halves x. And a 3 times a negative 1 is a negative 3. And that's equal to x plus 1, or 1x plus 2. Well, I know I'm going to have to move my x's, so I'm going to write 1x as 2 over 2x so that we have the same denominators, plus 2. Now I can subtract 2 over 2x from both sides. That leaves me with 7 halves x minus 3 equals 2. Then add 3 to isolate the x. 7 halves x equals 5. And then in order to fully isolate the x, I need to multiply by reciprocal. And if I do that, I get x equals 10/7. So this one is going to have one unique solution. My x value in my ordered pair is 10/7. Now I need to solve for y. So I'm going to take that 10/7, which is an x value, and every time I see an x, I'm going to plug in 10/7. And I can use either one of these equations. I'll just use the first one. It can be either one. Rewrite it. Y equals 3 halves times x, which is 10/7, and then minus 1. So that gives me y equals, well, I can simplify before I multiply. 2 goes into 2 once, 2 goes into 10 5 times. So I get 15/7. And then I want to subtract 1, which is 7/7. So I get y equals 8/7. Now I have a y value and an x value, so I can write my solution, which is my x value, 10/7, comma, my y value, 8/7. And that is the solution to this system. It's the only point that will make both equations true. It's also the intersection point if we were to graph them. All right, number 6. This is nice. X equals that. So whenever I see x in my other equation, I'm just going to plug in 12y minus 4. So I get 12y minus 4 is equal to 9y plus 7. And then I go about, getting all my y's on the same side. That gives me 3y minus 4 equals 7. Add 4 to both sides. I get 3y equals 11. And then multiply by reciprocal. And when I do that, I get y equals 11 thirds. So I know my y value. This is going to be one unique solution. Then I just use either equation. Doesn't matter which one. I'll use the first one again. Every time I see a y, I'm going to put in 11 thirds. So I get x equals 12 times y, which we know is 11 thirds, and then minus 4. And then simplify. Well, I know that 3 goes into 3 once, and 3 goes into 12 4 times. So this is 4 times 11, 44, minus 4. So x equals 40. And there are my two values. The x value is a 40. The y value is 11 thirds. And that is the solution to this system. It's the only point that makes both equations true, and it's our intersection of the two lines. Okay, last one today. We have to write a system of equations with 4, negative 5 as its solution. So whenever I put in a 4 for x and a negative 5 for y, it'll be a solution to these two equations. So there are a lot of things that I could do, but I could write it in slope-intercept form. But in this case, it might be better to use standard form. So let's say we had, 2x plus 5y. Maybe something like that. Well, my x value is a 4, so this would be 2 times 4. And my y value is a negative 5, so 5 times negative 5. And then all I need here is this simplified. So 2 times 4 is 8. And then a 5 times a negative 5 is a negative 25. So this is a negative 17. So 2x plus 5y equals a negative 17. That is one possible equation in my system. And then just make up another one. Let's say we did negative x plus y equals something. Well, again, my x value has to be a 4, so this is a negative 4. And my y value has to be a negative 5, so that's a negative 5. Put those together, I get negative 9. So this has to equal negative 9. And there's my two equations. And they could be anything. I could make up whatever I wanted as my coefficients, as long as I calculate what my expression on the left side has to be equal to if I use the solution 4, negative 5, this one here. So my system would be 2x plus 5y equals a negative 17, and a negative x plus y equals a negative 9. That's one possibility out of the infinitely many that we could create. All right, that is lesson 27. I hope that helps. See you again next time.